Okay, let's move on to moles and volume and see how those are related. Avogadro, along with coming up with the number 6.02 times 10 to the 23rd, also stated some things about volume and said that equal volume of gases, if we have them at the same temperature, we have them at the same pressure, they're going to contain the same number of particles. Now that might seem a little bit unusual because you might think, well, some are bigger than others, but that's true. Gases are not the same, but the fact is, like here's a gas molecule, here's a gas molecule. There's so much space in between that it doesn't matter if the molecule is that big or that big. So mostly it's empty space. So then the size of the molecule itself does not make much difference. It does make a lot of difference if we're talking about things in terms of mass of grams and so on, liquids and solids, but not in terms of volume here. What does affect it are pressure and temperature. More pressure, think about it, the more pressure you put on a balloon, you can push it in on something, you're going to push it on a piston, you're going to push that down. And the warmer it is, the more it's going to expand, or the colder it is, the more it's going to contract. You take a balloon and you stick it in a freezer for a little bit, it's going to contract. You take it out on a hot sunny day, it's going to get bigger. So it is important that we understand what temperatures and pressures we're working at, and so we just use a standard one that you should know. And standard temperature and pressure is 0 degrees Celsius, and it is 101.3 kilopascals, which in older terms it was known as 1 atmosphere, but in SI terms, and what we'll use is usually kilopascals, right around 100, but 101.3 kilopascals. If we are at STP, in other words, we're at 101 kilopascals, we're at 0 degrees Celsius, 1 mole of any gas is 6.02 times 10 to the 23rd particles. We know that. But more importantly now, something new, the volume is always going to be 22.4 liters. No matter what, we're going to have 22.4 liters if we're at STP. This is known as the molar volume. So we've got the number 6.02 times 10 to the 23rd. You also need to remember 22.4. So volume of gas, if we want to figure that out, we're going to take the number of moles we have, take times 22.4. That's it. If I have 2 moles, I would have 44.8 liters. Take a look at page 301. On page 301, we've got this problem. Sulfur dioxide is a gas produced by burning coal. It is an air pollutant and one of the causes of acid rain. Determine the volume in liters of 0.6 moles. Well, if we want to know how many liters, and we have 0.60 moles, all we have to do is we know 1 mole, and we're talking about SO2 here, it doesn't matter, but 1 mole of any gas, 22.4 liters, assuming we're at STP, and in this chapter we will always be at STP. So you're just going to take 0.6 times 22.4, and you're going to end up with 13 liters. Okay, would you guys try the bottom two here? Take a look at 20 and 21. Do those, and then stop the video and check back with me. Alright, so 20 says, what's the volume? So we want to know how many liters. If we have 3.20 times 10 to the negative 3 moles of CO2, and we know that 1 mole, CO2, 22.4 liters of CO2. So we're just going to multiply those two together, and that would give me 82.9 liters. Okay, for B, 3.7 moles and 2. Once again, 22.4 liters, 1 mole equals. Take 3.7 times 22.4, and Oops, I'm sorry, I wrote down the answer for the second one on the first one. So this one would be 82.9 liters. This one would have been 7.17 times 10 to the negative 2. That's what happens when I try to cheat and use the answer book. Okay, for 21, it says what volume do these occupy? So now we're still trying to find liters. 1.25 moles of HE. Yeah, take it times 22.4 liters, 1 mole, and we would get 28 liters. 28 liters. And the second one, we want to know how many liters. If we have 0.335 moles, same thing, 22.4 over 1 mole, kind of getting old, equals 7.50 liters. Not too bad. All right, now let's, one last thing here, let's calculate density. So from the mass, let's see if we can figure out density. Usually when we're talking about density in terms of a gas, we usually say grams per liter. If we were talking about a liquid, a lot of times it would be grams per cubic centimeter, which is 1,000th of a liter. But then we get some really small numbers. So usually grams per liter. Now it says the molar mass equals the density times the molar volume. Now, instead of memorizing a new equation, just remember that this is our old equation. Density equals mass over volume. It's the same thing. They just reworked it, took density times volume to solve for mass. That's all they did. So, if we want to, if we know the density, we always know the volume of a mole. It's 22.4. It's always 22.4. So we can always figure out how many grams we have if we knew the density and we knew, if we have a mole of that, we could figure out how many grams we would have in that particular instance. All right, let's do these last few problems. Look at page 302. And it says the density of a gaseous compound containing carbon and oxygen is found to be 1.964 grams per liter at SP. What's the molar mass of the compound? Well, we want to know the mass, so we want to know M. We know density, 1.964 grams per liter. And we know the molar volume because it's always 22.4 liters per 1 mole. And you'll see that liters will cancel and you'll get grams per mole, which, that's what we're looking for, the molar mass. So that's going to end up being 44.0 grams per mole. Probably carbon dioxide. All right, try numbers 22 and 23 right now, and we'll finish up with those. All right, so 22 says we've got something with a density of 3.58. What's the molar mass? So we want to know grams, and we know the density, 3.58 grams per liter. And we know 22.4 liters, 1 mole. Just multiply those out, and we end up with 80.2 grams per mole. And then the other one's a little bit different. We're trying to find density. So remember, this is our density formula, like that. So what's the density of krypton? Well, so we would need to know the molar mass of krypton. Well, that simply means take a periodic table, look it up, and we're going to see that that's 83.8. So I'd take 83.8 grams, and I know that that's going to be a mole, and 22.4 liters is going to be a mole. So I'm going to divide those two out, and I'm going to get 3.74 grams per liter. All right, last thing I want to show you here is this map, which is kind of helpful. It's kind of useful, but it kind of tells me what I'm going to do. So anytime that I'm going from grams, so mass, we're going to talk about that in grams, and I want to convert to volume, which we usually say, that's going to be liters. then I'm going to follow this path. I'm going to go this way to moles. Everything leads through moles. And then I'm going to go that way to volume. And so this is what I would do. I'm going to convert first to moles by dividing by the molar mass. And usually what I would say when you're trying to find this stuff, it's always, that's the periodic table. So you're always looking up the things on the periodic table. And then once I've got it in moles, now I'm going to use 22.4, convert to volume. Or maybe I wanted to go from particles to grams. Well, if I want to go from particles, I'm going to use this conversion right here. And then going this way, I'm going to use this conversion right here. So this is kind of a nice little table that you can use, and it's kind of helpful in order to make conversions between those two. So I think I've got a copy of that in Dropbox that you can pull up the PDF file if you want to see that. It might be a little easier than looking at this one. That would be it. You may now stop the recording.